Alright, so today we're going to look at section 8-4, which talks about what's called an angle of elevation and depression. The math is no different than what you've been doing. This is completely story problems, word problems. Yay! Very excited about that, I'm sure. So your job is going to be to draw a picture that describes the story going on. And oftentimes you're going to use these words called angle of elevation or angle of depression. So this is your line of sight. Your line of sight is always parallel to the ground. So if I'm looking out, I'm assuming that my line of sight goes straight out this way, is parallel to the ground. If my sight is elevated, doesn't that mean I'm looking up? Does that mean I'd raise my head and look up? So this angle that's created as I look up, right here, that's my angle of elevation. But if I'm depressed, what do depressed people tend to do? Their heads are down, they're sad, right? So if I look down, my angle is going to go down. So the angle from here to here is my depression angle. So you always have one line that's parallel to the ground, and then your angle is either going up or going down. So you have to determine what that looks like. So we're going to look at a couple of problems today. I'm going to have you work some problems in your homework tonight. It's going to be tricky, some of them, so I'm going to expect some questions tomorrow. And then we're going to go over some more problems tomorrow and some questions on your homework. So we're going to spend 2 days on this. So let's go ahead and look down below where I drew you a picture. So I went ahead and drew the picture here. We're going to get to one where you're going to draw your own picture. So this one says a surveyor, I'll grab my pens first. Alright, so a surveyor is 130 feet from a tower. So I just drew like one of those big power pole towers. For me, that's a pretty good picture. I'm very impressed with that. You may not be, but I am. And so it says a surveyor, this would be where your surveyor is. He's looking into that piece of surveying equipment. You've seen him in the street, right? Surveying equipment's probably a little taller than that, but that's all right. So he's 130 feet from a tower. Remember, you're drawing a right triangle. So you can kind of see the right triangle in here. My right angle is going to be right here. When we measure the distance that we are from something, typically we measure the distance from the center of the item out to where we're at. Wouldn't this distance from here to here be the 130 feet that they're talking about? So I'm going to label this part, and you can see my triangle in there, as 130 feet. Is my triangle off the ground or on the ground? It's off the ground. You'll see why in a minute. Then it says the tower is 86 feet high. So technically from here, the 86 feet goes from the top of the tower here all the way down to the ground, which is right here. That means this part, remember my triangle's off the ground. So my tower is taller than where my triangle is. Does that make sense? So this distance from here to here is not 86 feet. I'll show you how to calculate that in a minute. The distance from here all the way to the ground is 86 feet. And then it goes to say the surveyor's instrument is 4.75 feet above the ground. So this distance from here to here is the 4.75 feet. Oftentimes they're going to say to you, your eyes are 5 feet off the ground. Because it makes a difference if it makes a difference in my calculation of my height of my object. If my line of sight is 5 feet off the ground or 4.75 feet off the ground, I have to account for that difference in height. Otherwise, if they don't mention anything about, your eyes are 5 feet off the ground, you're going to have to assume your eyes are at your feet. Weird. But if they don't mention anything about how high your eyes are off the ground, that you're going to make that assumption. All cell phones are put away. Your job is to be learning, that physically put away, not on your desk. Your job is to learn in this class, not text. The question is find the angle of elevation. Where's your parallel line of sight? isn't this my parallel line of sight? Right? And if my angle of elevation is the angle of elevation, doesn't it go up? So then we're talking about looking up at the top of that tower. This distance, or this angle created right there, that's what they're asking you for. That's your angle of elevation, and I'm going to put X degrees there. So since I don't know my degrees, looks a little fuzzy. Is that fuzzy to you, or is it just me? Well, I can't fix it. Maybe if I zoom in. One more. All right, so I've got this side of my triangle, which is 130 feet. I almost have this side. If this distance from here to here is 86, and this distance from here to here is 4.75, because I know that this distance is 4.75 feet, how do I find this distance from here to here? Yeah, subtract. So we're going to take 86 feet and we're going to subtract 4.75. This is my bad green pen. We're going to subtract 4.75 feet. So take your handy dandy calculator. Remember to turn it on. It's in the lower right corner. 86 minus 4.75. So I've got 81.25. So I know that this distance from here to here is 81.25 feet. So I have this leg of my triangle, I have this leg of my triangle, which I had to calculate. I don't know my degree. So if this is my angle of reference, is this the leg opposite, the leg adjacent, or the hypotenuse? What is it? Opposite. Is this the leg adjacent or the hypotenuse? Leg adjacent. So this is my adjacent. So I have OA is at SO, KA, or TOA? TOA, T-O, so tangent. So I know that I want to find the tangent. I don't know my degrees, it's X degrees, is equal to my side opposite is 81.25 feet. My leg adjacent is 130 feet. My feet cancel out. And can't I determine what that ratio is? Now, you're going to learn how to use your calculator today to find that. Mathematically, this is what we're going to do. Well, first of all, look at your calculator buttons. See how your buttons have sine, cosine, and tangent here? What's above them? Sine of, looks like sine to the -1, cosine to the -1, and tangent to the -1. This is really, sine to the -1 is really the inverse sine, which means you're going backwards, or the arc sine, which we'll call it in pre-calc. You'll hear me call it in here the inverse sine. And this is the inverse cosine, the inverse tangent, meaning if I want to go backwards in my table. So remember, this is the type of problem where we went backwards in our table. We figured out what that 4-digit decimal was, and we took our table, our trig table, looking for my trig table. See, I didn't get my trig table out. Here it is. So we would look up that 4-digit decimal or trig table, and then we'd figure out what the angle measure was. Well, your calculator, you have to tell it that you want it to go backwards. So we're going to find what's called the inverse tangent of, so x is approximately equal to, when I have to go backwards, and we only use the inverse tangent when we don't know the degrees. You've got to get used to that. So x is the inverse tangent of, and I would put this whole thing in your calculator, 81.25 divided by 130. That's what your calculator is going to look like. So go to your calc, and here's the deal. One other thing you have to remember to do, you can't just punch it into your calculator right now. The graphing calculators are very sensitive. You have to change its mode. See the mode button right here? Aren't we working with degrees? You're going to find out within the next year that there's something called radians. Press your mode button. See, you have your normal flashing. If you cursor down, here's your cursor buttons right here. So cursor down, you got float, that means your decimal's floating. You see how that says radian? We don't want our calculator to say radian. Every time you reset your calculator for me, like you did yesterday, second function plus 722, it resets your calculator to what's called radians. We need our calculator in degrees because I'm trying to find x in terms of degrees, right? So you need to cursor over to the right, you need to highlight degree, and you have to press enter. So now I've got degrees. If you're not sure that you did it right, hit second and then quit, which is your mode. Second and then hit mode because you're quitting. You're back to your screen. Then you can hit mode again. And what's highlighted this time? Degree. That's what you want. Does everybody have degree highlighted? Okay. Because otherwise your answer is going to be different than mine. And so I will remind you when you use my calculators to change your mode to get it into degrees. Okay? So now we have our mode into degrees. Don't touch it anymore. And then we're going to go to our calculator. I'm going to clear out my screen just so you can see what I'm doing. And I'm going to do the inverse tangent. To get to the inverse tangent, don't I need to get to my blue? To get to the blue keys, you have to hit this blue second function key. So hit second function. You see an arrow flashing up there. And then you're going to hit tan. Doesn't it look like 10 to the negative 1? It means we're going backwards in the table. And you're going to put in that ratio that you're trying to find. Our ratio is 81.25 divided by, see if I can get that on the screen, divided by 130. And you have to hit end parentheses. Is everybody there? Now you can hit enter. Round to 2 decimal places. So that's 32 degrees, so it's 32.01. So x is approximately 32.01. I'm going to prove that this is correct, and this is in degrees. I'm going to put a degree marker. I'm going to prove this is correct because we're going to find this decimal equivalency and look it up on our table. I'm just going to prove to you it works. So 81.25 divided by 130 is 0.6250, right? So 6250, because I'm using tangent, I'm going to look on my tangent for 6250. Well, those are way too high. Here's my 4s, my 5s, well, here's 6s. 6249, and then it gets bigger this way, right? So shouldn't my degrees be in between 32 and 33? What do we end up with? 32.01. It was really, really close to 32. And isn't 6249 really, really close to 6250? So do you agree that your calculator works? Now, if you're doing this and everything's right and you're using your graphing calculator at home, what did you forget to do if the answer is wrong? Change your mode. So you do have to, if you're going to use your graphing calculator at home, check your mode. If you're using a scientific calculator, you don't have to worry about your mode. Scientific calculator doesn't, it's not this big thing. Anybody have one on them? Anybody have one that's not graphing? It could be anything. Here, bring that up. So this is what a scientific looks like, and you don't have to worry about it on the scientific. So you can use these at home. So this is a typical scientific, right? And you see the keys here, sine, cosine, and tangent. And above them are also sine to the negative 1, cosine to the negative 1. Those are your inverse. To get to these, because they're in blue, you have to use your blue key. So same thing here. Turn it on. I want my inverse tangent, so I'm going to hit second function tangent, so his looks like mine. And I'm going to put in, I don't have to check the mode, because this calculator will automatically do it. So 81.25 divided by 130. Enter. Do we get the same answer? Yeah. If you're uncomfortable at home and you still have your trig table, go ahead and use your trig table. But I still want to see this proper math here. But you might want to put here instead the 4-digit decimal that you're looking up in your chart. But I need to now start to see this. If you're going backwards in your table or backwards on your calculator, you'll pass this back to Tony. I need to see the inverse tangent, inverse sine, inverse cosine. Question? Yes. From now on. Because you're telling yourself and me that we're going backwards to find it. Okay? All right, so then, therefore, the angle of elevation is 32.01 degrees. Military artilleries use this all the time. They have to know the degree of elevation in order to shoot their rockets off, to blow things up, whatever those things might be. I won't go any further with that. All right, so now take your study guide out. And you've got a picture on the study guide. This is an example of an angle of elevation. Let me just show to you, doesn't this create a rectangle? And isn't this angle of elevation right here the same degree as this? Wouldn't this be an angle of depression right here? If I change my line of sight from here to up here, wouldn't that be a depression? Aren't these alternate interior angles? Aren't they the same? So you can switch from an angle of elevation to an angle of depression and vice versa, should you want to. Like, I don't like to look at triangles upside down, I like to look at them this way. So oftentimes you'll see me switching, even though the problem might be talking about an angle of depression, I might switch to an angle of elevation. So we're going to look at, let's see, I want to look at number 1. And then we'll do the other 3 tomorrow. So we're going to draw a picture, and we're going to do it, you can do it on the back of yours, you can do it on a piece of paper right next to it, it's your choice. So from the top of a tower, the angle of depression to a stake on the ground is 72 degrees. Well, they're a little vague here, but they're attaching a guide wire to a stake, probably. So in my 4-step plan, if I could get this over here, I have some sort of tower, whatever, some sort of tower, right? And then attached to this tower, there's some stake over here on the ground. So they're saying, and they mention nothing about, you know, the top of the stake is so many inches or feet off the ground. You haven't heard any of that. So we're assuming that we're going from the ground directly to the top of the tower. This is my line of sight to the tower, and there's the middle of my tower, so there's my right angle. So it says but this one says the angle of depression to a stake. So if they're talking from the top of the tower, wouldn't that be my line of sight here? Isn't this right here the angle of depression? I don't like to look, and then this creates this triangle here where my right angle would be there. I don't like to look at angles of depression, personally. I'm going to switch it to my angle of elevation because that's more reasonable to what I want to do. So instead, I'm going to let this be 72 degrees here instead of my 72 degrees up here. I'm going to put my 72 down here. Usually with angles of depression, that's what I'll do. There's a rare occasion where I won't. And then it goes on to say that the top of the tower is 80 feet above the ground. Are they referring to a slanted height, a vertical height, or a horizontal height? Top of the tower is 80 feet from the ground. Vertical, horizontal, or slant? Vertical. So isn't this right here 80 feet? And it says, the question is, how far is the stake from the foot of the tower? Is that this distance from here to here? Or is that this distance from here to here? Yeah, the stake from the foot of the tower. So if you trace from the stake to the foot of the tower, this is what they're talking about. So I would put my X there. Since I know my degrees, I'm not going to use inverse sine, cosine, or tangent. I'm going to use a direct sine, cosine, tangent because I know my degrees. And so now I can take the problem away and just work it. So if this is my angle of reference, is 80 the leg opposite, adjacent, or hypotenuse? Opposite. And X, is that the leg adjacent or the hypotenuse? Adjacent. So again, with OA, what are we going to use? TOA, tangent, right? So I've got tangent. This time I know my degree is 72 degrees equals, my ratio is opposite over adjacent, so 80 over X. If my variable is in my fraction, I want to turn this into a proportion and cross multiply. So I've got X times the tangent of 72 degrees, and since we're using our calculator, we're not going to replace this with this decimal. I'll show you what we're going to do. Equals 1 times 80, which is 80. How do I solve for X? divide by tangent of 72 to both sides. Those cancel. And I have x is approximately equal to. This right here is what we're plugging into the calculator. Again, remember your calculator needs to be in degrees because you're plugging in 72 degrees into the calculator. You might have to turn your calculator back on. Clear your screen. And then we're just going to take 80 and divide it. You don't need to use parentheses because you're just putting one thing in there. You're going to hit tangent of 72. I typically will put an end parentheses here. Probably not necessary, but get in the habit of using your end parentheses. And then hit enter. And then round that to 2 decimal places. What do you get? You do have to pay attention. The directions might say round to the nearest foot. Did they say anything here? Angles are to the nearest degree. All right, so that's not what we're looking for. Round measures of segments to the nearest hundredth. So if I'm going to round this to the nearest hundredth, how many decimal places is that? 2. So it's 25.99, right? So 25.99. Look back at your picture. X is a measurement, and isn't it in feet? Therefore, the stake is about, because we estimated, 25.99 feet from the foot of the tower. So the only new thing you really learned was what's an angle of elevation, what's an angle of depression, and then how do I go backwards in the calculator. So you're going to practice that today. Your assignment is 422, 8 through 20. I will be collecting it tomorrow. I won't be giving you an extra day on it. So if you need help, you need to come in for help, call each other, ask for help, phone a friend, right?